So we're still in section 4.5, and this is a video on writing a polynomial function with the given zeros. So I'm going to do number 42 from your book. So it's given that -4, -2, and 5 are the zeros. So if I were to write these out, it would look like, and remember, when it's in the parentheses, it's always the opposite. So this is going to be x plus 4, x plus 2, and then x, since positive 5, minus 5. That means that this polynomial crosses the x-axis at -4, -2, and 5. So now we're going to go backwards. So here are the answers, and we're going to work by multiplying to get the full polynomial function. Okay, so I'm going to first multiply these two together. So remember, x squared, 2x, and then 4x makes 6x. 4 times 2 makes 8. And then that I'm going to multiply with x minus 5. So again, try to do them one at a time. This makes x cubed plus 6x squared plus 8x. Now we do the -5. -5 times x squared is -5x squared. Then it's minus 30x minus 40. And then we're going to collect like terms. It's going to be x cubed plus x squared, because now we're adding them, minus 22x minus 40. So that is the original problem, and we've been factoring. So if I were to factor this out, especially using the rational root theorem, I would find out that -4, -2, and 5 are my zeros. So I just finished a problem with you where we had some rational roots and we were able to create a polynomial from that. Now we're going to use the irrational conjugates theorem that says on page 193, if it is given that this irrational number, a plus radical b, is a root, that its conjugate, which is a minus radical b, is also a root. We're going to be doing example 5 on page 193. Okay, so now we'll be doing example 5 on page 193. It says, write a polynomial function with a leading coefficient of 1 and has the zeros of 3 and 2 plus the square root of 5. Now, since this is an irrational number, knowing the irrational conjugates theorem, it means that 2 minus the square root of 5, its conjugate, is also a root. So there's really 3 roots. Okay, so we're going to write them as binomials. So since this is positive 3, it's going to be x minus 3. Since this is positive 2, it's going to be x minus 2 plus the square root of 5. And since this is positive also, it's going to be x minus 2 minus rad 5. Okay, so we're going to first work on this problem. And what we're going to do is we're going to use the associative property. So we're going to move things around. It's going to get kind of complicated, so watch carefully. I'm going to leave x minus 3 there. Okay, now take a look at this. I'm going to distribute this -1 that's here. So it's really x minus 2 minus square root of 5. Now this one, same thing. I'm going to distribute this -1, so it's going to be x minus 2 plus square root of 5. Now, I'm going to group these, because once I group them, you're going to see that it has something that's common. So, x minus 2, I'm going to group that together, and then x minus 2, I'm going to group this together. Now, I know this is difficult to see, but I'm going to put it here on the side. If you notice, x minus 2, consider that as just a. Pretend that's a. Minus, pretend that's b. Now look at this one. Again, pretend that this is a. And this one's going to be plus b. If you can recognize this problem, it's actually a dots problem. And the way that you solve a dots problem is you square the first, you square the last, and the sign in the difference of two squares is always subtraction. So, knowing this from Algebra 1 and the review of Algebra 2, I'm going to solve this problem. This is actually a very complicated looking dots problem. So I'm going to take this first term and I'm going to square it. I'm going to take this last term, I'm going to square it. So the square root of 5 times the square root of 5 is just 5. And the sign in the middle is going to be subtraction. Whew. Okay, now before I multiply these together, I'm going to multiply this whole thing out first. So what it really looks like is this. X minus 2 times x minus 2 minus 5. So let's simplify that first. X minus 2 squared is x squared minus negative 2x, 4x. Negative 2 and negative 2 is plus 4, and then I'm going to do minus 5. Now this one, obviously, we're going to simplify this to be x squared minus 4x minus 1. Almost there. So now I'm going to multiply this entire thing, this binomial, with this trinomial. So we'll do them one at a time again, and I'm going to stack them so it's easier to see. X times x squared is x cubed. X times negative 4x is negative 4x squared. X times negative 1 is negative x. Okay, now I'm going to multiply negative 3 with everything. Negative 3 times x squared is negative 3x squared. I'm going to stack it with the other x squared. Negative 3 and negative 4x makes positive 12x, and that makes positive 3. Alright, so now we're going to add them all together. I'm going to bring down the x cubed. This becomes negative 7x squared. This is positive 11x, and this one becomes positive 3. Whew. So there is my original polynomial that has the roots up here. If I were to factor this of 3, 2 plus rad 5, 2 minus rad 5. Okay, so I'm going to do Monitoring Progress 7 as another example. I know this is very difficult, so I'll try to go slow. Let's try to do it again. Okay, I have a irrational root here, so that means that I know that 1 plus radical 5 is also a root. Okay, so I'm going to write my binomials. Remember, it's always the opposite, so this is going to be x minus 4. This one's going to be x minus 1 plus rad 5. And this one's also going to be x, because positive, minus 1 plus rad 5. Okay, so just like the example 5. Alright, now remember this. I'm going to distribute this negative 1 that's in front. So this becomes x minus 1 plus rad 5. This becomes x minus 1 minus rad 5. And remember, because of associative property, we're going to group, so I'm going to group these two together. And again, hard to see, but if you look at this term as A and this term as B, and again look at this term as A and this term as B, I want you to recognize it as a dots problem. Okay, so let's square the first. So remember the answer to this. So we're going to square the first. There's A, quantity squared. We're going to square the last, which just comes out to be 5, and the sign in the middle is negative, subtraction. Okay, I'm going to multiply this whole thing out. So what it looks like is x minus 1 times x minus 1 minus 5. Just a little bit of room. This becomes x squared. Negative 1 and negative 1 makes negative 2x plus 1 minus 5. I'm going to simplify that to be x squared minus 2x minus 4. Okay, now that I'm going to multiply with x minus 4 binomial. Again, one at a time. X cubed minus 2x squared minus 4x. Okay, next one. Negative 4x squared plus 8x plus 16. Now I'm going to add them together. X cubed minus 6x squared, right, plus 4x plus 16. And there is my original problem. If I were to factor that, my roots would be 4, 1 plus rad 5, and 1 minus rad 5.